Hello, folks. Are we alone in the cosmos? An interesting topic. Before answer to this question, we should understand that the elementary compounds that make the life we know of are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And these are common in our cosmos. Therefore, it is not an accident we are made of them. They are all made from star stuff. All heavy elements are from stars. This is why we make a statement calling that we are all stardust. Some interesting facts. Organic molecules and volatiles are found at the surface of planet Mars, in the geysers of ring planet Saturn's moon Enceladus, in the atmosphere of Titan, another moon of planet Saturn, also the captured moon of planet Neptune, which is known as Tritons at stratosphere, and also on several comets have been discovered. Scientists also have discovered on many asteroids and dwarf planets. One of the dwarf planets, which is called Ceres, which is in the asteroid belt between planet Mars and Jupiter. Also, scientists have found traces of molecules and volatiles in planet Pluto, which is our dwarf planet. These are only examples within our solar system. Scientists also have discovered nearly 200 types of prebiotic complex organic molecules in interstellar clouds near the center of the Milky Way galaxy. Some science facts about our solar system, which is in the suburban region of the galaxy. The approximate distance to the center of our galaxy is about 26,000 light years. A light year is a distance light travels in 1 year. So light zips through the interstellar space at 186,000 miles per second or 300 kilometers per second, and 5.88 trillion miles or 9.46 trillion kilometers per year a light travels.
The interstellar clouds could play a role in forming amino acids, the building blocks of the life we know. Again, please note, when we say we know of means, we have only experienced life on Earth so far. Organic molecules are not life, but they are the elemental building block life uses for its carbon and hydrogen. There are sheer numbers of possibilities that add to the probability of an abundance of life in our universe. A basic extrapolation of German mathematician Johannes Kepler's data on the number of exoplanets in our galaxy alone suggests that tens of billions of Earth-sized planets could be located within the habitable zone. Our galaxy holds roughly over 300 billion stars. Kepler's data suggests that there must be at least 10 billion Earth-sized planets orbiting in a habitable zone of Sun-like stars. A habitable zone means a planet can hold its atmospheric conditions for life to exist. Suppose only one planet in a billion has developed a type of life, made it to higher levels of complexity and intelligence, and then nearly a dozen advanced civilizations could populate in our Milky Way galaxy alone. Presently, scientists have an idea of roughly 2 trillion galaxies in our observable universe. If each galaxy on average holds 200 to 300 billion stars, then roughly as many as an estimated 10 to the power of 24 more stars than all the grains of beach sand on the Earth can exist. Even if it were 1 per 100 galaxies, there could still be billions of lives in our universe. Probability distribution in nature predicts more puddles than large lakes, more small buttes than Himalayas, more small planets than large ones, and more simple life than complex life. It follows that the universe is likely teeming with planets harboring simple life. What precedes is an obvious oversimplification, but it is not an unreasonable one, and there are several possible scenarios. We should remember that the Earth might not be a gold standard as how rapidly life develops. It took over 80% of our planet's geological evolution to reach complex life. Our home planet has been buzzing around its parent star for about 4.5 billion years. There is fossilized evidence roughly 3.5 billion years ago of single-celled organisms from Pilbara in Western Australia. Scientists call that their knowledge is still modest and imperfect, particularly for these deep times of early Earth, since plate tectonics and erosions have destroyed most of the ancient geological record. Moreover, life could be a result of generational process associated with the formation of specific stars, in our case, sun-like stars.
Let me conclude with our Milky Way galaxy, which was formed roughly 13.6 billion years ago, roughly 200 million years after the Big Bang. But it did not produce sun-like stars right away. The older stars were called population 3. They short-lived to about 2 to 5 million years. They were massive, luminous, and hot stars existed very early in the universe. Most of these stars virtually had no metals in their composition. Scientists have only indirectly observed of a galaxy seen through gravitational lensing in a faraway regions of the universe. I have produced a video on gravitational lensing and will tag it below. Death of these massive stars produce population 2 stars, which are more recent but metal poor in comparison to population 1 star like our Sun. The death of population 3 and 2 stars produced the heavy elements now being used by life as we know it. The biogenic elements that make life on Earth are most abundant in the universe, except for phosphorus, which was later delivered onto Earth by comets and asteroids during the heavy bombardment period about 3.8 billion years ago. Our universe has produced biogenic elements for a very long time, which is demonstrated by James Webb Space Telescope with the discovery of complex organic molecules in a galaxy which is about 12 billion light years away from Earth. Life developed on Earth and maybe elsewhere because they became sufficiently abundant from which most recent population 1 stars. If life as we know it is indeed associated with the birth of specific stars, then the universe could just be starting to blossom with cradle of life. I hope you enjoy this video. Please share, like and subscribe. I will continue with this video because it doesn't justify discussing life on Earth or space or in the cosmos in one video. Thanks for watching. Have a great day. Bye.